So because of the field trip and the ice step and not figuring out exactly how everything's going to go with our schedule, I'm going to do a video on this one as well. Once again, just trying to get everything taught to you that I possibly can and trying to stay on schedule because I still have health to get to this year. So one of the things I want you to understand is that we have energy and it is cycled through, like this says, on our planet, just like the 3 different cycles that the book is going to mention to you. So since the energy cycle is not mentioned in here, I'm going to reference it because it takes us back to the last video that I just made. In that video, we talked about how energy flow happens from food chains and food webs and food pyramids. But there was always that idea that the decomposers are down at the bottom, and when something dies up here, it gets decomposed down here. That is the energy cycle. The energy cycle for food energy talks about how we have the sun with the nuclear energy that is transformed by the producer. The producer creates sucrose, and then it gives it to that first level consumer. So that was going to be changed into ATP. And then that ATP gets eaten by the secondary consumer. And that ATP gets consumed by a tertiary or a third level consumer. And then when the top of that food chain dies, it goes back to the soil and decomposers begin to break it down. And that energy gets added back into the soil. And the soil then releases that energy in different gases and minerals and vitamins, and the plants get it out of the soil, suck it in through the roots, send it up throughout the plant, and it's healthy. So that energy cycle is constantly cycling through our planet as well. Now our book focuses on 3 major cycles. One of them we've already mentioned when we talked about water and things like that. It's the water cycle. It has 3 different levels of the water cycle, or 3 different stations, if you will. And all 3 states of matter are included and shown in the water cycle. So I wanted to review the states of matter as I'm talking about so you remember what they are. And the states of matter, now there is that one that's kind of in the mix. It's not included in the picture, right? So magma is not really solid, it's not really a liquid. Okay, but you know what we're talking about. So when we have solid, it's when our molecules are packed tight together, like this desk here. It's nice and hard. It's a solid form. It's not real wavy. If I push on it, it's not going to collapse and bend and things. So solids, we know, are hard with molecules all pushed together. Gases is where the molecules are loose and free. You have gases all around you, and I don't get hurt and bump into things as I'm walking across the classroom because they just flow freely around me. And then the liquid is in the middle. They're touching, they're connected, but they flow freely. They can break apart and come back together, but they are closer than the gas. Okay? So when we talk about the solid, liquid, and gas, then when we look at the steps of the water cycle, I can see those different states of matter throughout it. If we start with evaporation, evaporation is when liquid water, now that can be anywhere. In the picture we see a lake or maybe the ocean, we see a pond or maybe a lake, we see rivers, streams, mud puddles. When it rains here we have mud puddles everywhere. All of that water on the soil or on the ground. When it gets heated by the sun and it turns to 120 degrees, it gets warm enough to break its bonds from liquid and it goes to a gas. And we call that gas that's in the air around us water vapor. And there's water vapor all around us. And if you don't believe me, if you take a nice cold pop can that's nice and dry and you sit it down on a table, you're going to get water particles all collecting around it. And magically, water is coming onto that can. It appears that maybe it's seeping out of the can, but it's not. That can is nice and sealed. What's happening is the water vapor around you is warmer than the can, and because it touches something that's colder, it causes those particles to collect, and I get water droplets. Condensation is when I'm going in that gas form and I go higher and higher and higher. So in our atmosphere, we have higher temperatures, but then the higher we go, the colder it gets. So just like with that can, condensation is when those water particles, that water vapor, begin to collect around dust particles, and they make these crystals, and we call those clouds. And we have different types of clouds in our atmosphere, in our stratosphere, and our mesosphere. But when I look at them, it's just water particles stuck together, crystallized. Okay, so that's our solid form. And then when those clouds get up and they begin to collect and they get bigger and more dense and they get heavy, then in that atmosphere they begin to go down. And then as they go down in the atmosphere, then the temperature gets warmer. And then I begin to see, because the clouds are so heavy and carrying all those crystals, that it begins to fall in the precipitation. So I can have rain, snow, sleet, or hail in forms of water falling from the sky. Could fall in the solid form, or it could fall in the liquid form. So when I talk about those stages then, when we look at the picture that is showing you, I want you to fill this out in your book. When it says that evaporation from the ocean, evaporation from the lakes, evaporation from plants. We talked about transpiration when we talked about plants and how they give off liquid. But any type of water that's sitting there, when it gets warm enough, it's going to evaporate. So that's your evaporation. And then when they go high up in that water vapor, they begin to crystallize and form solid little teeny tiny icicles around each other, or snowflakes even around each other. But they form around dust and pollution that's in the air, and they make a cloud. And that's why when you have rainwater, if you look at it under a microscope, you're going to see all sorts of little particles sitting inside of that water. And it's not that the dish or the plate was dirty, it's the air's dirty. And it collects and it cleans our air for us anytime the precipitation comes down. But that cloud is condensation. It's that solid form, those feather-like crystals of water as they freeze. And then when that cloud drops down in temperature and the cloud becomes dense and heavy, then it's going to fall as snow, rain, sleet, or hail, and we have precipitation. So when I talk about the water cycle and we ask, well, what is the first step then of the water cycle? Then we know that that's a false statement, right? Because it is a cycle. And that's the whole idea of a cycle. There's no beginning, middle, or end. As evaporation is happening, precipitation is happening somewhere else, condensation is happening somewhere else. It doesn't just start. It just continues on and on and on and on, and there isn't a beginning, middle, or end. They all happen at the exact same time. That's something that is in common in all three of these cycles that our book talks about. Carbon and oxygen then. When we talk about carbon and oxygen, we have carbon, and carbon is given off in a couple of different ways. And we've talked about both ways now. We've talked about how oxygen is given off by any plant. And when that plant takes in the oxygen, then when the animal takes in that oxygen, it exhales, and it gives off carbon dioxide. Now in our reading books, we also talk about Greensburg going green, if you've gotten to that story. And it talks about how we also release carbon into the atmosphere by burning fossil fuels, like the gasoline and the oils that we use, and coal for our power plants and just to get around. So we are constantly adding carbon into the environment. And then how does it get out? Well, then the plants, as we mentioned up here, take in the carbon dioxide, and they add water to it and oxygen, and they go through a process called photosynthesis. And photosynthesis then has a byproduct of oxygen, and that oxygen leaves the plant. So we have a cycle that's constantly going around. Oxygen leaves the plant. Animals breathe it in. Animals exhale carbon dioxide. Carbon dioxide is taken into the plant. Oxygen is given off. And it's a cycle. There's no beginning, middle, or end. But it's vital that we try to find a balance here. And right now we have so much carbon that's being built up on our planet, and we're eliminating our oxygen supply by clear cutting. So an example of that would be if I look at this area and we see that we have phytoplankton out in the water, and we have all of this greenery that's producing oxygen, but man's not really there polluting it or causing problems. But someone discovers that lake. And so once they discover that lake, they put in their cabin, and they're out there boating, creating some carbon. But there's enough individual organisms out here to break down the carbon that's being added and changing it into oxygen. But when more people find out about it, then we have more people creating that carbon. They drive on their boats, and they're living in their homes, and they're spreading the news. And eventually we have to add a gas station. So we take off all of this top layer of soil, and we pave it over, and we add a gas station. So we eliminated some of the producers, not a great deal. We still have all of the greenery back there, so we should be okay. But as areas begin to build up, you have more and more things coming in. Somebody buys a big piece of the property, kind of like on the edge of Jamestown with the big factory, and they take out all the trees, the shrubs, the grass, and they pave it over, they put in a big factory, and then that factory adds carbon into the environment. And another one shows up, and we take out all of the producers. And then, when there's a bunch of people, then we have to have shopping malls and areas to get our food and grocery stores and things like that. And the number of, or the amount of carbon that increases goes over and over and over again. But then what happens is people start investing in all of these trees, and they go through and they start doing what's called clear cutting. My mom and dad's cabin down in Tennessee, you can look at several of the mountains where sides of the mountains have just been wiped away with trees. Because lumber companies have come in and said, hey, I'm buying this lumber. And they cut every single tree down off of that mountain. And now I have erosion problems, I have mudslides and rock slides happening, and I'm eliminating nature's way of taking care of all of this carbon that's been added. And if I eliminate the way that that nature is taking care of the carbon that's in our air, we have the greenhouse effect. And we're going to have constant temperature changes and climate changes. We're leading to a lot of problems. We have to make sure that when we cut down trees that we replace trees so that we don't interrupt that process. The last one is, which is not something that you and I have talked about in 6th grade. I don't know if you heard about it in 4th grade or not, but it's the nitrogen cycle. And the nitrogen isn't being exchanged with something else, like the oxygen is exchanged with carbon dioxide and vice versa. There are two different forms of nitrogen. Nitrogen is either in what is called a free state or a fixed state. Now, if it's in the free state, that means it's in the air around you. You're breathing in nitrogen right now, as long as you're breathing. If you're not breathing, then we got a problem. But 78% of the air around you is nitrogen. The only difference is your body doesn't recognize nitrogen through your lungs. Your lungs can't process nitrogen, so it takes it in and spits it right back out when you exhale. There's no identification markers in our cells that says, hey, there's nitrogen in the air, I need that, I'm going to take it in. Our lungs don't work that way, our blood and our body cells don't work that way. But most of the free air around us is free nitrogen. Fixed nitrogen has to be attached to something that is consumed. Organisms can only get nitrogen through their digestive system. Now, nitrogen is a gas, but it fixes itself to other elements and it becomes more of a solid compound. So once again, when we talk about elements, we talk about atoms, the base unit with the nucleus and that has the neutrons and the protons in the center and the electrons on the outside. Nitrogen is one of them. It will attach itself to several different things. And then when I have them in my digestive system, then my cells say, hey, look, in this food there's nitrogen. We need that to be healthy. And they pull that nitrogen out. When we talk about what it's fixed to, so here's a list of the things that are in your book. I'm thinking some of these you probably don't eat. Clover, not something that most of us would eat. I know I don't. Beans, though, yeah, beans and peas. Alfalfa, nada, I don't eat alfalfa. Peanuts, and there are some trees. So I don't go around eating a tree either, I'm not a beaver. But some trees, some of the nuts, like cashews and Brazil nuts and things like that, would have nitrogen in them as well, which is what it's talking about. But that nitrogen has to be fixed. And what the book is showing us is that organisms that eat these different things, so consumers, they eat parts of the producers. And there's bacteria inside the nodules, which are in the roots of these different organisms. And it fixes nitrogen into the product that that organism is creating. So in the clover where the flower is, when that flower top is eaten and the leaves are eaten, there's nitrogen inside of them. The organism eats it, digests it, and their digestive system breaks the nitrogen out. But then, when that organism dies and the decomposers get a hold of it, then those nutrients get returned to the soil. And that soil, in the soil, is where they get affixed to the different producers that get consumed by the consumers. That's why we get nitrogen into our body. Nitrogen is important to be healthy, but I can't breathe it in. There's no way that my body would identify it unless I digest it. This is just another example of the cycle of how nitrogen is around us. Nitrogen is all over the air, and some plants will be able to get it out of the soil. However, it's in the soil where these bacteria put it into the plants that consumers are going to partake of. When those organisms then die, they return their nutrients, including the nitrogen, into the soil, where the bacteria of the plants also add it back into the plant, and it continues to cycle around. No beginning, no middle, no end. A cycle is something that continues and is going on in all stages at all times. So those are the 3 cycles in your book. You have your assignment. Should be able to get it done, I'm hoping, in class and not have homework tonight.